In this video, I will provide you with a relatively simple, easy to understand math formula to calculate the spans necessary to figure out the roof rafter lengths for a building where you have a wall on one side of the gable roof that will be a little taller than the wall on the other side. And I realize this isn't going to be that common of a problem, and hopefully it'll make sense. So what we're going to need to do first will be to calculate the length here so that we can get the total span of our imaginary building from the difference in the wall framing heights to basically figure out the center of the roof or the roof rafter span on the other side. And then after we figured that out, we can just simply subtract this measurement from the measurement of the span on the other side to get the span over here that we're looking for. So the difference in our wall height is going to be 12 inches or 1 foot. And we're simply going to do a little multiplying and dividing to figure out the length of this measurement here from the height of this measurement here, along with the pitch of our roof. So let's go ahead and get started by adding some numbers and taking away some of the framing so that we can end up with some triangles here. And of course, you can pause the video at any time you need to, or grab a piece of paper and a pencil and start breaking down some of these numbers to see if they make sense. So let's go ahead and get started with the plate height difference of 12 inches here and use it to figure out the length here. So the roof pitch we're dealing with here is a 5 and 12. And that means for every 12 inches in horizontal length, we're going to go up 5 inches. So to find this length here, we're just simply going to divide 5 into 12 to come up with 2.4. And this would basically represent 2.4 segments over here to provide us with the length. We're going to multiply 2.4 times 12 inches to arrive at 28.8 inches, or 2 foot 4.8 inches, or basically 2 foot 4 and 13/16 inches, just a little bit over 2 3/4 inches. And if you remember, our original span here is 20 foot. Let's go ahead and pan out. If we add this number here to 20 foot, we're going to get this number here or something close to it. And this is going to be the overall imaginary span of our building. Once we divide this number in half, it's going to provide us with the center of the building and the span of this section here so that we can use this to calculate our roof rafter lengths. And to get this side here, the measurement from here to here, all we need to do is subtract this number here from this number here to get this number over here, or the span on the right side of the building that we're going to use to calculate the length of this rafter here. And hopefully that makes sense. I'm only going to provide you with one example here. However, if this doesn't make sense, you're having a problem with it, feel free to leave a comment in the comment area and let us know, and I'll be glad to make another video with a few more examples. But for the most part, I think this is self-explanatory. To find this length here, the imaginary span of the building, so that we can divide that in half to find the center of the ridge, then all we need to do is use the height difference of the framing plates and then divide the first number of the roof pitch into that number and then just simply multiply that number by 12. So if I had a 6 and 12 roof pitch with a 1 foot difference in the framing plate heights, I would simply divide 6 into 12, which is going to give me 2, and then multiply 2 times 12. This measurement here would then be 24 inches. If I had a 4 and 12 roof pitch, I'm going to divide 4 into 12 here, and that's going to give me 3. I'm going to multiply 3 times 12. That's going to be 36 inches. The length here I would need to add to my 20-foot span would be 23 feet instead of 22 foot 4 and 13/16 inches that I would have on a 5 and 12 roof pitch. In this video, I will provide you with a couple of different ways to calculate the wall framing stud measurements for a chimney. And for the most part, this information should apply to both new construction and remodeling, or adding a chimney to your house. So the first thing I kind of want to point out is that the wall framing studs are usually going to sit on top of a wall framing plate, and the thickness of that wall framing plate will need to be calculated into your measurements, along with the wall's top framing plates and anything else you're going to be adding to the wall framing. So with that said, let's just go ahead and take a look at a measurement you could take here from either the top of the building foundation or the top of the wall framing plate to the bottom of the sheathing, and then add for the thickness of the sheathing as one way to get a starter measurement. However, I don't think that's going to be necessary because you're going to be able to measure it from the top of the bottom framing plate to here, and then do some simple math to calculate the rest of the wall framing chimney stud. So here you can see where we've just placed a stud here. You can use your measuring tape. You don't need to put the stud here, and then you're going to mark the top point where the wall framing stud meets the roof sheathing. So not too difficult there. The next step will be to either use a simple math formula to figure this height, or grab a 10-foot 2x4 and then place this end on top of the roof sheathing. And then once it is level, you can go ahead and mark the bottom. Remember, you don't want to be marking the top, you want to mark the bottom. Next up, let's take a look at another problem you might have. In our example for our framing, we are going to be building a wall on top of the roof. So the 10-foot measurement is going to need to come from this point here and not this point here. So keep this in mind. It's not just this point here. It's going to be the measurement off of the top of the roof sheathing, where the farthest point of the chimney on this side is going to intersect with the roof sheathing. Not always going to be this point right here. So let's go ahead and put our mark in there. And this will make a little more sense when I provide you with a final example of what the chimney is going to look like. In our next example, we will put the chimney on the other side of the house and go ahead and break out our long stud and our level with our straight edge. And you can always use this method here to calculate the height over here, especially on an existing house. So we're going to need to plumb this board in both directions so that it is vertical. We're going to be using that for our measurement. Or you could always measure from here to the fascia board on the top and transfer that measurement to the bottom. And you don't need to be right on the money here. I think as long as you're within an inch, you're going to be okay. I'm also nailing two 2x4s together here to provide those of you with another option if you can't find lumber long enough to calculate the chimney stud height. And again, we are going to make a mark on the wall framing stud even with the top of the sheathing. And I guess now would be a good time to point out that if you are going to get this as close as you possibly need to the minimum chimney height, then make sure that you take into calculation your roofing materials and anything else that is going to be on top of the roof that could create a problem for this measurement. Now in this example here, we do not need to go back 10 feet. We are at the top of the ridge. However, if you are going to move the chimney over, keep in mind that you need a 3-foot minimum height for your chimney. And the 10-foot by 2-foot measurement that we're used to isn't going to do you any good here. 3 foot is the minimum height for a chimney. And I do have another video on that. I will put a link to that in the video comment area. And again, we are marking the bottom and not the top. Why am I saying this? Because while I was making this video, I marked the top of it. And you could end up making the same mistake. Try not to do that. Make sure that you're measuring off of the correct spot. And of course, the minimum measurement we're going to need to add will be 2 foot. And the same measurement will apply to the other chimney we were building. Now, just to be on the safe side, keep in mind these are minimum measurements. You might want to make it a little larger. And that's what I did when building the 2 chimneys. Instead of going with 24 inches, I made this measurement 30 inches. So 30 inches from this point here to the top of the chimney wall framing studs. And this measurement will work for all of the framing studs as long as you're dealing with a level concrete pad or a level foundation. And let's go ahead and wrap this video up by taking a look at the completed wall framing for our chimneys. And as you notice, this one here is a little taller than this one here. The farther you go up the roof, the taller the chimney is going to be. So keep this in mind if you're not interested in building a huge chimney when designing your project. Try to put them at the bottom of the roof. And this is probably the most common location you're going to find for a chimney, especially for home builders who know what they're doing. Now here's the example of what I was talking about. We're not going to be coming off of this mark here. We're going to need to add 3.5 inches to it. This will be the point we're going to be coming off of. The farthest point of the chimney facing the slope of the roof, or the slope of the roof that we're going to be getting our measurements from. And try to keep in mind this video is just on calculating the wall framing stud heights. And there's usually a little more work that will need to be done to these fireplace chimneys. And I think I'm going to create a follow-up video. However, I don't know when I'm going to do it. But try to create a follow-up video on how you can calculate the height of the chimney wall framing by the components you're going to use to assemble a prefabricated metal fireplace. In this video, I will show you how you can figure out the framing square measurements if you need an exact angle, something like 22 degrees, 27 degrees, or 35 degrees, instead of the odd angles you usually get if you use a 5 and 12 roof pitch or even a 6 and 12 roof pitch. And the angle for a 6 and 12 roof pitch is going to be 26.6 degrees, or if we want to take it one more decimal, it's going to be 26.565 degrees. So almost right in between 26 and 27 degrees. And that would look something like this on our framing square, where we're going to have a 12 and a 6 lining up on the framing square to create a roof pitch of about 26.6 degrees. Now, what if I wanted to create a 28 degree angle for my roof pitch? And to do that, let's go ahead and break out our calculator. And to do this, I'm going to need a scientific calculator with the trigonometry functions. And I'm simply going to enter the amount of degrees that I want and then push the tangent button. And then I'm going to multiply that by 12 because I'm going to be using a 12 unit measurement on the framing square. If I wanted to change this unit of measurements, I would simply enter that number in. So let's go ahead and multiply this by 12. And that's going to provide us with a 6.38 measurement. So instead of using 6 on the framing square, I'm going to use 6.38 as a decimal, or convert this to a fraction, which would be just a little bit over 6 3/8 inches. And that would look something like this on the framing square. 12 unit measurement down here, or 12 inches, along with 6 3/8 inches on the other side of the framing square. And I do have other videos on how to use a framing square to lay out roof rafters. Make sure you check those out at our website if you need a little more information about using a framing square to lay out a roof rafter. And if that makes sense, you can stop watching the video. If it doesn't, I'm going to go ahead and take a 30 degree angle here and see if I can create the roof framing ratio for you. Now a 7 and 12 roof pitch is 30.256 degrees, and the number we're going to be looking for is just going to be a little bit under 7 inches. So let's go ahead and grab our calculator. We're going to enter in 30. We want 30 degrees. Then we're going to pull up our tangent key. Your calculator might have the tangent button right on the front of it. Then we're going to push this button and then multiply it by 12. That's going to give us 6.928 inches. Or we can round this off to 6.93 inches. or about 6 15/16 of an inch. And to convert the decimal to 16ths of an inch fractions, we can simply start by dividing 15 divided by 16 equals 0.9375. And that's pretty close to the measurement we're looking for if we're going to use the framing square to lay out our roof rafters. If not, we can use the exact decimal. We can take it to hundreds or thousandths on the decimal to calculate the exact length of our roof rafter. Here is another question from one of our viewers. They wanted to know how you could raise the risers on a stairway. And I'm guessing that you would be raising the risers if you raised a deck, porch, landing, or floor. And if you did that, then you could add materials to the top of each step. However, you will not be able to add the same thickness to each step. For example, in this situation here, we raised the platform 7 inches and we have 7 risers. However, we will not be able to just simply add 1 inch to each one of the steps to solve this problem, because all that's going to do is make a difference at the top and the bottom. It won't make any difference at all to all of the steps in between. So to solve this problem here, we're going to need to increase the increments of each step by the difference between the existing riser and the new riser height. And to do that, you can simply measure each one of the existing risers. And if they're the same size, great. If not, maybe grab a piece of paper and write down the individual height of each step, or the riser height for each step, and then divide the overall height that you've added to a new floor. For example, we have 7 risers. We've added 7 inches. And if I divide 7 into 7, I'm going to get 1 inch. And that's the amount we're going to add to each step. So 1 inch at the bottom, 2 inches on the next one, 3 inches on the one after that, and then 4 inches, and then of course 5 inches and 6 inches. And in this video, I'm not going to go over how you're going to add the materials, because I have plenty of videos on that. Check out our riser variation videos. And don't forget that you can always remove the existing stairway and replace it with another stairway if adding materials like this won't work for your project. In this video, I will provide you with an estimated size for your roof rafter seat cuts. And the seat cut is located at the bottom of the rafter. The plumb cut or the ridge cut is located up here. And this is a question that seems to keep popping up over and over again, even though I've mentioned it in a variety of different videos. And one of those questions is the size right here, and the other is the size right here. And you can kind of get an idea by watching the rest of the video that one of the sizes will dictate the size of the other size. For example, if I make this one longer, then this one here is going to be longer. And if I make this one here shorter, this one here is going to be shorter. And I'm not about to suggest that's going to happen all the time, but the main part I'm going to focus on in this video, the most important one to me, is going to be this cut here, or the level cut. And I would like to see this at least 2 inches long. However, I've seen them as short as 1.5 inches before. And there are very few cases where this cut right here, the plumb cut on the roof rafter, is going to matter as much as this one over here. So let's go ahead and take a look at another consideration you might have, and that will be the width of the wall framing top plate. Here we have a 2x6 that is 5.5 inches wide with about 3 inches here. So 1.5 inches down here. And I believe we have a 5 12 roof pitch and a 2x10 roof rafter. And from what I gather from most engineers, once we put a notch in a piece of lumber like this, we're going to reduce the strength for the lumber supporting the overhang. So here we're going to have 8 3/16 inches out of a 9.5 inch 2x10, which should be strong enough for most 2-foot long overhangs. And of course, this brings me to another problem with the seat cut length, especially when referring to heavier roofing materials like tile that might require wider lumber for your overhang, or loads from snow setting on your roof for a long period of time that might require a wider overhang. I will not be able to provide you with information for those lumber sizes. You'll have to check with a structural engineer for that. Another thing that can affect the length of the roof cut will be the pitch of the roof. Here we have a 2 and 12 roof pitch with a 2x10 roof rafter that has an 8 5/8 inch measurement from here to here, along with about a 2 3/4 inch horizontal seat cut measurement and a plumb cut measurement of 7/16 of an inch. However, if I change the angle to a 12 and 12 pitch, I'm going to reduce this measurement here considerably if I keep the same measurement of 5.5 inches for the horizontal seat cut measurement. And with this example and the previous example here, you can get a pretty good idea how I won't be able to provide you with the exact measurement. However, by the time you finish watching the video, you should have a pretty good idea why sometimes they're going to need to be a little longer than a little shorter. In our next example, let's go ahead and reduce the horizontal seat cut measurement to 2 3/4 inches to provide you with an example of how this measurement here will increase by reducing the length of the horizontal measurement. Now for the grand finale in the video, let's go ahead and change the 2x10 to a 2x6. And if we keep our 2 3/4 inch horizontal seat cut measurement, we're going to reduce this measurement here to about 3.5 inches, which by now should give you a pretty good idea how some of the different roof pitches and material sizes for your roof rafters can significantly reduce this measurement here, suggesting that if we can reduce the horizontal measurement here for a seat cut, we might choose to if we're going to be using smaller lumber or dealing with steeper roof pitches. And we're going to be using ceiling joists. Now this is the key here, because we're going to be able to get more nailing with our ceiling joists. We're going to be able to connect the roof rafters to each one of the joists. And then we can put more nails in the framing plates. Maybe 2 from the roof rafter going into the framing plate, and then 2 more from the ceiling joist going into the framing plate, and that will be on both sides of the roof rafter and the ceiling joist. If possible, along with the nails, we're going to be able to drive in through the ceiling joist or through the roof rafter on the other side into the ceiling joist to create a nice connection. So if something like this will work for your project and you don't have a choice, then you might have to use it. Another option might be structural hardware that might provide you with even a better connection if you have to use smaller seat cuts. And the last tip I want to provide you with in this video, and it might not work all the time because you might be dealing with a different roof, would be to drive around your area to see if you can find a similar roof, similar to the one you're planning on building, and then check out the materials they used for their overhang, for their roof rafters, and for their seat cuts if you can see them. If not, at the very least, you'll have a pretty good idea about the material sizes to build a 2-foot or a 16-inch overhang for a roof in your area. Here is another question one of our viewers had. They wanted to know how to figure out the length for a ramp. And according to the ADA, the American Disabilities Act, they would like you to go out 1 foot for every 1 inch of vertical height. So if we were going to go up 4 inches, we would need to go out 4 feet or 48 inches. And I'm not about to suggest that you can't increase this angle to make it steeper. However, I can suggest if you're going to get something approved by your local building department, then there's a good chance you're going to have to use this formula. So again, 10 inches in vertical height, 10 feet in horizontal length, and not 9 feet. You can't make it shorter. You can make it longer, but you can't make it shorter. Here is a little something that you might not be aware of, especially if you've never designed a house before or remodeled one. And that will be the fact that the window headers and the door headers, the bottom of each, will usually be installed at the same height. So in other words, the top of the door will dictate the height of the top of the window and not the other way around, because windows can usually be installed a little wider and longer. And I'm not about to suggest that you cannot install a window at a different height or create a bunch of crazy different patterns. And for those of you looking for that measurement is usually going to be 6 foot 10 inches, because most doors are about 6 foot 8 inches. However, you would need to check with your manufacturer to verify that information. And I'd be willing to guess that this measurement probably applies to more than 80% of the homes built, and probably 90% of the homes that I worked on. In this video, I will provide you with simple and basic instructions. I will not be walking you through the entire step-by-step process for framing a long wall by yourself. Now, this wall could have been broken down into sections and framed because there were 3 carpenters on the job, but I chose not to. And the reason for that, if you can see, we have 4x4s over here. 4x4s that have hold downs bolted to the building foundation. We have a raised floor, and I thought that it would be structurally stronger if we could bolt the 4x4s to the building foundation instead of setting them on top of the wall framing plate and then using a longer hold down or some type of a connector to connect it to the building foundation. And hopefully that makes sense. So all I did here was fastened the framing plates to the floor and then installed each stud separately. And you see, I don't have any braces at all holding this thing up. And the reason for that would be obvious. I have the 4x4s in here already that aren't going to allow the wall to fall over. However, that won't be the case most of the time. So basically, if you have a long wall, you're simply going to start with your framing plate. Attach it securely to the foundation, because a framing plate is going to help support the vertical wall framing studs. However, this won't always be the case. You might need to install additional braces or build one section of the wall at a time. Next up, let's take a look at how the wall framing studs might be attached to the framing plates. And that would be with 2 16D nails on one side and 1 16D nail on the other side. And when I first started, this method right here was the preferred method on most of the architectural building plans. However, it was rarely used. So I think the best way for most of us to get started would be to attach a couple of the wall framing studs to the framing plate and then install some type of bracing to prevent the wall from falling over. And again, this is just additional insurance. And obviously this video isn't for people who've done this before. It's more for people who haven't done it before and are looking for a little guidance. So I would definitely suggest installing some type of bracing, whether that's at the beginning of the wall framing like we're doing here, or when you get a little bit further, maybe where you have 5 or 6 studs attached and the wall seems a little flimsy. And of course, you can always install additional bracing and bracing going in the other direction. These braces here will prevent the wall from falling over. This one here will prevent it from falling in this direction or leaning a little too far in this direction or this direction. Next up, let's go ahead and install our wall framing studs. You can install them one at a time, working your way down the line. I just wouldn't go too far without installing the top plate. Or you can install the top plate first and then install your framing studs and then build one section of the wall at a time. So you could use whatever length you're using for your top plates to create one section of the wall. Finish this section of the wall framing, make sure that it is securely braced, and then build the next section. Here is another question that I have received quite often, and people want to know, where do the tread sizes come from? And for the most part, they're going to come from your local building code books or local building department officials who can provide you with the minimum sizes for your stair steps. And this is going to be the width and the depth. And again, I said minimum sizes. These minimum sizes will be anywhere from 9 to 10 to 11 inches, depending upon what project you're going to be working on, or whether or not it's going to be for commercial, industrial, public, or private residential home use. And then once you have those measurements, you can go ahead and lay your stairway out on the ground. And that might look something like this when you're done. You might have a landing and then 5 steps. And if the minimum building code requirement is 10 inches, then something like this might work. And keep in mind that even though the depth of each one of the steps is the same, this stairway has 6-inch riser heights going all the way down. This one here has 8 inches. And again, this will be another thing you're going to want to check with your local building department. And I wouldn't be surprised in the future if they change these numbers also. And like I said, you're going to be better off if you don't know a lot about stair building. And that will be to lay out the basic design of the stairway on the ground or on your building foundation floor or even on a sheet of plywood, something that will provide you with a design of the stairway that can be used to pull measurements from if needed to build your stairway. So again, check with your local building department to find out the minimum and maximum sizes for your treads and risers, along with the minimum width of the stairway before building your stairway. In this video, I will provide you with something that will help you figure out where your clogged drain could be. And even though I will be focusing on a bathroom here, you could apply this information to the rest of your house. So let's go ahead and get started. Here we have a toilet with the plumbing drain pipes, and we have a cutaway of a bathtub and a sink. And what inspired this video was someone asked what the problem could be if they have a clogged sink and a clogged bathtub, but not a clogged toilet. So with that said, let's go ahead and reverse everything and start with a clogged toilet. We have a clog in our drain pipe, and the water would be backing up into the toilet. However, we'd be able to use our bathtub and our sink without any problem. The clog is behind these pipes here. So with the clog located right here, all of these drain pipes would be open and allowed to flow to the sewer or our septic tank. However, that will not be the case if we move the clog a little farther to where we'd be able to use our sink, but not our bathtub or our toilet. And if we move the clog a little further down, we're not going to be able to use anything in our bathroom. If every fixture in your bathtub is filled with water or won't allow any of these fixtures to be used, then there's a good chance the clog is located a little further downstream than the clogged fixtures. Now, before we leave this illustration, I want to point out that the water level is usually going to be consistent or level. So you could have a situation where you think you can use the sink, but once you start putting water in the sink, the bathtub and the toilet level will rise. So you might think you can use the sink, or this might provide you with the illusion that you can use the sink, but obviously you won't be able to. Any water that goes into here will just simply raise the levels of the other fixtures that are upstream of the clogged drain pipe. And this could include other fixtures throughout your home, like a kitchen sink or a wash machine drain line. Now, since you probably don't know which direction your drain line is going, let's go ahead and flip this thing around and allow the drainage wastewater to go out in the other direction, along with providing an example of what it could look like if you have a sink that is plugged. However, you'd still be able to use the bathtub and the toilet. And before we get carried away here, if you do have an individual plumbing fixture like a sink, a bathtub, or a toilet, it wouldn't be a bad idea to run some type of a snake through these individual plumbing fixtures, because most of the time the clogged drain pipe is going to be in the trap. So make sure that you check the sink trap first, or the traps in the other fixtures, if that's going to be easy. If it's going to be easier for you to run a snake through the drain line, then do that. Just run the snake through the drain line. If that doesn't work, then you're going to have to come back and focus on the traps. And as you guessed it, if we move the clog a little farther down, we're going to back up these two fixtures. And if we move it a little further down, we're going to block up the rest of the bathtub. And if we move it a little further down, we're going to block up the rest of the bathroom. And again, if you have a clog in the drain line, there's a good chance the water level is going to remain the same. It's going to be level in all of your fixtures. This won't be the case if you have a clog in the individual pipe leading to that individual fixture. If I have a clog here, then I'm going to be able to use the sink and the toilet. If I have a clog here, I'm going to be able to use these two fixtures. And if all of this makes sense, you can stop watching the video. If not, let's go ahead and take a look at a house with the drainage pipe system in it. We're going to have a wash machine drain here, along with our kitchen sink over here, and our sink, toilet, and shower drains over here. So a small house. Let's go ahead and take a look at the kitchen drain line, and that would be coming in right here. Let's go ahead and head over to the other side to suggest that if any of this right here is clogged, you're not going to be able to use the kitchen sink. And like I said, if it's easier for you to just simply unscrew the clean out on the outside and run a snake through here, then do that first. If not, take a look at the kitchen sink trap. And a good clue, if you do remove the clean out cover and no water comes out, then there's a good chance the kitchen trap is clogged. If water does come out, then there's a good chance the drain is clogged. So be careful whenever you're opening a clean out inside, because you could get a lot of water coming out of it. Next up, let's go ahead and head over to the laundry area. Any clogs in here, right here, is just going to prevent the wash machine drain from working. However, that won't be a problem if you have a clogged line going to the kitchen sink. Because if the pipe is clogged right here, the water is still going to be able to flow out of here and down through the pipes to the sewer. And by now, hopefully you're starting to wrap your mind around what I'm talking about, with a clear understanding that if you don't know what your pipes look like, you don't know what they look like underneath your house, then you're going to need to do a step-by-step drain cleaning. Again, starting with the traps if that's easier, or clean outs if that's easier. So if I had a clog anywhere in this area here, the sink wouldn't work, but everything else would. If I moved the clog over to this area here, the toilet and the sink won't work, but everything else will. If I move the clog to this area here, everything behind here throughout the rest of the house, which would be the toilet, bathroom sink, washer and dryer drain line, and the kitchen sink. However, our bathtub or our shower here would be working just fine. And if the clog's a little farther down the line, anywhere located here, or going towards the sewer, then there's a good chance you don't need to worry about cleaning out this section here. If all of the drain lines in your house are clogged or not draining properly, then there's a good chance the clog is going to be located somewhere further down the drain line. And if you do have a clean out in front of your house, this is going to be the place to start. See if you can run a snake through this line to get rid of the clog. Then if not, you might want to go to the back of the house if you have a clean out located back there, so that you could run a drain line all the way through. Because unless this is a clean out that allows you to go in two directions, allows you to go this way, and the clog is located right here somewhere, you're gonna have to somehow run a snake through this line. And if you have access to a clean out right here, give it a shot. However, if you do have a clean out at the back of the house, then this would definitely be my second choice. First choice here, second choice back here, for a problem with the main line. So I'm not going to be able to provide you with every single problem you're going to run into, but this is a good place to start and should be enough basic information to allow you to locate a possible clog in your drain pipe. However, if it is not, make sure that you go to the website, click on the repair tab, and then find the plumbing repair section of the website for more videos that might provide you with enough information to solve your problem. In this video, I will provide you with an easier way to locate the plumbing drain pipe holes. This might even be able to be used for your vent pipes, anything that's going to be at an angle. And for the most part, if your joists are spaced equally, 16 inches on center, for example, then you could calculate the distance for each floor joist that the line would need to raise. So for example, if I needed to raise each one 3/8 of an inch, then I would simply start by adding 3/8 of an inch here, 3/4 of an inch here, and then 1 1/8 inch here. And again, you could do this if the joists are equally spaced, or 16 inches on center, for example. However, in our example, I'm going to go ahead and move the joist around and make it a little more difficult to locate the center of the holes that would need to be drilled through each joist to provide you with 1/4 inch per foot slope, or whatever slope you desire to have in your plumbing drain or vent pipes. And to do this, we're simply going to start by creating a center line for the pipe. So you would need to locate the center of the fitting here and then transfer that measurement to another joist that might extend a little further than you need to. Then we will use a straight edge or our chalk box to snap a straight line to connect the 2 points together. And then we're going to use a framing square or some type of a square or even a level to create a plumb line or a square line off of the joist. And make sure that the line extends far enough so that you won't need to draw your line again when you are calculating the location of the center of the pipe. And to find the center of the pipe, usually the pipe fittings have little lines on the side, and you can usually measure from those lines that could be used to calculate the center location in both directions for that particular fitting. Because we are going to need the center of the pipe fitting, otherwise the holes for the pipe could be a little off center, and that's going to create an assembly problem when you go to put everything together. Now I'm going to provide you with 2 different methods to do this, and of course the first method might not be necessary, but it's going to give you a better idea of what I'm doing. And we're going to start by attaching a piece of scrap wood to the bottom of the floor joist. This board right here. The width of this board right here should be the same as the measurement between the front of the fitting and the front or face of the wall framing. Same distance as the block thickness, because this is where the slope of the pipe is going to be starting from. And keep in mind that this method will be reversed if the pipe drain is going in the opposite direction. For example, this pipe is going to be draining towards this drain pipe and therefore sloping towards this pipe. However, if it's going to be sloping away from the pipe, and this will be the high point and the low point will be at the other end, then we're simply going to reverse the process I'm providing you with in this example. Now I went ahead and drew a center line here and cut the block at the depth I needed for the slope to work out, and I'll go over that here in a little bit. So again, we can see where the face of this block, this side right here, lines up with the face or the edge of this pipe fitting. And yours might be different. It might be longer or it might be shorter, depending upon where that fitting is going to be located. Now I'm coming down 1 3/4 inches, and the reason for that is because I'm going to be going back 7 feet. And if I wanted 1/4 inch drop and a 7-foot horizontal measurement, I'm going to multiply 1/4 inch by 7. And that's going to provide me with 1 3/4 inches or 1.75 inch drop. So I'm going to be connecting a string to this point here on this side and to this point here on this side. And the screws should look something like this. You're not going to screw it in all the way on either side. And the string will need to connect at the top of the screw or nail. You can't have it connecting down here or down here unless you're going to do the same thing on the other side. And in our next example, I'm just simply going to use a block of wood. And this block of wood here will represent the depth of what I need at this end of the line. So you don't have to use 7 foot. If you're going to use a 4-foot piece of lumber for a 1/4 inch slope, then you would simply use a 1-inch thick board. You're only going to be dropping 1 inch. And I do have other videos on how to calculate the slope for your drain line. So in this example here, I'm just kind of giving you an idea of what we need to measure and what we're going to do with those measurements. I need to measure from the bottom of this board to the center of the fitting. And if this block is level, which it should be, you should be able to measure from the little tab or the mark that represents the center of the fitting on the outside of the fitting. So I could just simply measure from the tab here straight down, or measure from the top or the bottom and then calculate the center. And in our example here, this just so happens to be exactly 5 inches. And no, I did not plan that, but it does work out every once in a while. And you can see here where I'm just simply going to measure from our string or our straight line and then go up 5 inches. Not going to be that difficult, and there's no complicated math here. We're just simply going to come off of our straight line with the same measurement to find the center of the hole that needs to be drilled in our joist to provide us with the slope we need for our plumbing pipe. So again, the string represents the slope, along with the same equal measurements from that string will provide us with the center of the pipe location. And hopefully by now you're starting to wrap your mind around what's going on, and I can go ahead and show you how a plumber might do it. And that would be to get the location of this measurement here and this measurement here, the measurement from the bottom of the joist to the center of the pipe fitting, and then transfer that measurement to a piece of lumber. And in this example here, I'm going to transfer that measurement to the rim joist in hopes of making more sense out of what I'm trying to explain. So again, we're going to take the center measurement here off of the face of the fitting and transfer that to another piece of lumber. And then we're going to create our 1/4 inch slope along with laying out all of our floor joist and then using the measurements on this board here to locate the center of the holes that need to be drilled in each joist. So let's go ahead and go out 7 feet like we did before. And then we're going to measure from the bottom of the joist to this line here. That is also the center location of our plumbing fitting. And then we're going to transfer that measurement over to here and then raise it 1 3/4 inches to provide us with a 1/4 inch per foot slope. So let's go ahead and take a look at it from the side here. 7 feet. Then we're going to square down or plumb down so that we can create our slope for the plumbing pipe. So over here we have 2 13/16, and we're going to transfer that measurement to the other side and then add our 1 3/4 inches. Then we're going to draw a straight line or snap a line between these 2 points here to provide us with the slope we need. After that, we're going to transfer the measurements for the joist. And you'll be able to do that by measuring off of the face of the wall framing or off of the face of the plumbing fitting. Just make sure that all of your measurements are on the same side, if possible, even though it won't make a difference with this method. I could actually draw a line from here down or from here down. I'm still going to be in the same general path that we need for our slope. And again, you don't need to lay it out on the rim joist. You can lay it out on a piece of plywood or a straight piece of lumber. Or you could even lay it out on the building foundation. And each measurement that we need is going to be right here. We're going to measure from the bottom of the joist to the center of the plumbing pipe fitting hole we're going to drill through the floor joist. So not too difficult. Over here we have 4 5/16 from the bottom of the joist to the center of the hole we're going to drill. And we're just simply going to transfer that measurement over to here so that we can create a nice line of slope without using any complicated math. And if one or all of these make sense, then I did my job, and make sure that you let us know by hitting the thumbs up button. Here is another one of these stair building tips that might not seem like it's the #1 best tip in the whole world, but it is something that could save you a lot of frustration as a do-it-yourselfer or even a professional home builder. And the situation I see all the time, whether I'm working on a project or driving by one, is that they will build the floor first and then install the stairway. And I'm here to tell you that you need to build the stairs first to locate the stair headout, and then build the floor if possible. If not, then it wouldn't be a bad idea to pre-cut your stair stringers to verify the measurements for your headout before you build the floor. So let's go ahead and take a look at what the stairway should look like. And you might be working on a project that has a set of plans. And the plans usually show the upper floor line and the location of the stair steps. However, most stair builders, including myself, rarely build them to those exact specifications. And a good example of that would be if we come down here. You'll notice that the front step right here does not line up with the edge of the stairs. However, this side here will line up. We'll take a look at that here after we look at the headout and the floor sheathing to provide you with an idea of where the last step will be located on the upper floor. And if you have a situation like this, you can build the landing and the steps below first, and then draw a line on the landing where you want the front of the stringer to line up with. And you could even install a block here if you need to prevent the stringer from sliding down while you're holding it up on the other side. And to find this position here, you're going to need to subtract for the width of the stair riser and the nosing if it's going to have one. And in this situation here, we're going to have a 3/4 inch thick riser with a 1 inch overhang, suggesting that this needs to be moved back at least 1 3/4 inches. And then after we have that, we can just simply cut one stair stringer. And if you have a situation like this, you can pre-cut the stair stringer and then use it to locate the stair headout or support beam. However, if that won't work for you, you can always have the stringer run a little longer and then line it up with the measurement you've selected that will work best for the upper floor framing. Because sometimes if you have a situation like this and it doesn't line up, you can recut the stair stringer, lay it out with smaller or larger steps, as long as they meet your local building codes. Again, providing us with a good reason why we only want to lay out one stair stringer. And like I already said, I can't tell you how many jobs I come to where the stair stringer is off an inch or more because somebody built the floor first or didn't know how to locate the stair headout. So if you're not really good with math, your stair stringer measurements might be off a little bit, or you're just looking for the easiest way to locate the support beam or stair headout in the floor framing, then this just might be your best option. Here is another helpful tip for anyone who is building, repairing, or remodeling a stairway that uses metal brackets to connect the treads to the stringers and would like to relocate the treads either a little farther forward or a little further backwards. And the first thing I want to point out is that the riser height will not be affected at all by moving the treads forward or backwards. And for the most part, by moving the treads forward or backward, you're not going to affect the bottom distance between the front of this tread and the front of this tread. Or in other words, the measurement that is going to be measured by the building inspector. And I do have other videos on that in our stair building code area at the website if you're looking for more information on how to calculate that measurement. However, at the top of the stairway, you're going to have a problem unless the floor, landing, or deck framing is done incorrectly. So in our example here where everything is done correctly, we have an 11-inch measurement between the front of the step and the front of the floor framing. And at the bottom, we have the same thing. We've got 11 inches between the front of the step here, back here, and the front of the step above it. And if you notice the distance right here, we're going to go ahead and change it. We're going to move each one of the steps 2 inches forward. And for those of you who guessed it, at the top, we're going to have a 2-inch gap now between the back of the tread and the floor framing. However, like I said, the riser height wouldn't have changed on this, but the length of the last tread is now 2 inches longer. We have a 13-inch long step at the top. And to fix this, we're going to need to add a filler board to the back of the tread and extend the length of the floor framing by 2 inches. Now, this is one way to fix this. You can add or subtract materials at the top to compensate for whether you're moving the treads forward or backwards. Or we can remove some of the material from the stair stringers. If I take 2 inches off of both sides of the stair stringers, I can shove the entire stairway forward, go back to the original framing, and everything will work out just fine. And if you notice, I drew this line here. This is the same line I drew in our first example and kept it there as a reference point so you can kind of give a better idea of what we're doing. In this video, I will provide you with a few different ideas on ways you can save money by reducing the size of your fascia board. So let's go ahead and take a look at our first example here where we have a standard roof rafter, a 2x6 with a 2x8 piece of fascia board. And this method, of course, without a doubt, is the most common method used by builders. You're simply going to use fascia board that is a little bit larger than the roof rafter. 2x6, 2x8. You have a 2x4, maybe you're going to have a 2x6. Or you can have a 2x6 roof rafter and a 2x6 piece of fascia board. However, this usually isn't that common. And the reason for that is some fascia board is actually a little smaller than the roof rafters. For example, if I have a 2x6 that is 5.5 inches wide, I might have a piece of 2x6 fascia board that is 5.25 inches wide. And if that was the case, I would either need to lower the fascia board to where it was even at the bottom and then create a problem with the roof sheathing, or raise the fascia board to where it's even with the top of the roof rafter and then have a 1/4 inch gap between the edge of the fascia board and the roof rafter. That usually doesn't look very good. And of course, if I want to use a 2x4, I can simply shape the bottom of the roof rafter. And that can be done a variety of different ways. And this would be one of them, simply going from this point here to this point here, or a 3.5 inch measurement this way, and then going to the bottom of the roof rafter seat cut. And you can get as creative as you want to. The only thing I don't recommend doing is making this smaller than 3.5 inches. And of course, we can rip the tails. This is another common method. I've used this one a lot. Even if you have 2x6 roof rafters, you rip the tails down to 3.5 inches or even 4.5 inches. Or I hate to say it, even 5 inches if your fascia board is going to be wider than 5 inches. 5.25, 5.5 inches. Then everything should be fine if this is a 1/4 inch, a 1/2 inch, or even an inch smaller than the fascia board. And of course, this is a little old school, going back to a 1x4. Instead of having a 2x4, you can have a 1x4. Instead of a 2x6, you can use a 1x6. And again, if you're looking to save money, then this could be exactly what you're looking for. And if the rafters are a little wider, you can always put a little design on the end of the rafter tails. And of course, this design here would create a stronger roof overhang than it would if you ripped this down to 3.5 inches here. However, this wouldn't be something that's going to save a home builder money because this could be labor intensive here. And if that's the case, something like this might work a little better. Again, going from the bottom of the seat cut to the edge of what would be the fascia board measurement. And again, this could always be a little smaller. If you have 3.5 inch 1x4, you can always have this line come up to maybe 3.25 inches if that's going to work for you. And my last example would be to use a 1x4 and then create a level line across the bottom of the roof rafter. Something like this could be used for a flat soffit. Just make sure that you leave enough room here if you're going to put some type of plywood or siding covering the soffit. And to make this work and keep your 3.5 inches at the very end of the rafter tail, you might need to install a larger piece of fascia board, maybe a 1x6 or something 4.5 inches wide. And the last thing I want to mention is something I used on a variety of different projects. This might work for you, might not. And that would be to rip a 2x6 in half or a 2x8 in half. 2x6 would give you 2 3/4 inch wide fascia board, and a 2x8 might provide you with up to 3 3/4 inches in width for your fascia board. And don't rule out that a 2x10, 2x12, or 2x14 might provide you with the perfect size lumber for your fascia board. However, make sure that you do the math here and make sure that you're actually saving some money, because it's going to cost you a few dollars to rip that lumber in half or even rip it into thirds, whatever's going to work better for your project. Here is another video in our series on building different types of A-frame homes. And in this one here, we will build a roof that will shed a little bit of the snow easier than in the previous example. And there were a few comments in the previous example that suggested what a horrible design it was. And I'm not going to argue with that. I'm just trying to provide different ideas in the video for people who might be building something like this. So let's go ahead and get started and take a look at our back wall. We are going to have a 2x4 wall in the back, a 2x6 wall in the front. And we're also going to extend the wall to sit on top of the roof sheathing. On the 24 12 pitch roof on the main house, we're going to have a 12 12 pitch on the garage. And again, a 2x6 wall here. That's so that we can put a larger beam in for the garage door header. And if you notice, we're going to have double trimmers here. You might even do better off with a post, maybe a 4x6. And don't bother asking what size lumber I'm using in the video, because I can't provide you with the lumber sizes you're going to need in your area. If you've watched enough of my videos, you know that. And you can always make the back wall a 2x6 if that's something you need to do. And in this video, I'm not going to have a door coming from the main unit here, the A-frame, into the garage, and part of the reason for that is the drop that I have here. You can see the difference in the floor, and it looks like it's a little bit over a foot. That's going to create a problem for our door opening. However, I'm not about to suggest that you can't modify it to create a door opening from this side of the building into the garage. Next up, let's go ahead and install our rafter ties. If you want to install ceiling joist, you can. We're going to use rafter ties here going in this direction, and then some ties going in this direction. We're actually going to connect it to the rafters in the A-frame part of the home and run it all the way across to connect it to the exterior wall here to give it some support. We don't want the wall moving, and these braces will help with that. And of course, I have two of them flat, one here flat, and one on edge to provide you with a different example there of how you might connect them, along with how they might connect to the rafter ties. And here I had to attach a couple of blocks so that I could connect the brace that will be thoroughly nailed to the other support brace that will be sitting on top of the rafter ties. And you should attach all of this stuff together. End nail the flat board to the rafter tie, toe nail this board to the rafter tie, and again, you can just end nail, drive some nails down through the 2x4 into the rafter tie, and then drive some nails through this 2x4 into this 2x4, and then some nails to connect the rafter here to the brace. And hopefully you don't need more information on that. I don't put a lot of nailing information in the videos. They're kind of more meant to provide you with design ideas. And I'm kind of going on the fact that you already know how to connect this stuff together. If you don't, I do have plenty of videos showing you how to connect everything together. And you can find those on our website. Let's go ahead and add our rafters. Again, a 12 12 roof pitch. And each one of the rafter ties will connect at 4 foot on center to a rafter so that we can get a nice connection all the way through here. Rafter ties are 4 foot on center. Our rafters are 16 inches on center. So every third rafter will connect to a rafter tie. And the rafter ties are used to prevent the walls from spreading and the ridge from sagging. And again, I do have more information on that at our websites. Let's go ahead and put our fill in. Zoom into the bottom here to give you an idea how the rafters are going to be sitting on top of this wall here. And I went ahead and put my stud underneath the rafter since I'm going to have a single plate here. If you want to add another plate, then this wall stud doesn't need to be directly underneath the rafter. Next up, let's go ahead and take a look at the ridge. And I went ahead and had the ridge sit on top of our support boards here. You can always have the ridge sit on top of the sheathing, but I went ahead and did it so that I could show you how these support boards basically go up and kind of form a peak here, where if I was to run this through and have it sit on top of the sheathing, I just wouldn't have this. And I would imagine some engineers would rather have the ridge sit directly on top of these support boards instead of the roof sheathing, especially if the ridge won't be sitting on top of a rafter. Next up, let's go ahead and head over to the other side. Give you an idea how the sheathing is going to kind of connect into here, run straight on through. And since this is a 45-degree angle, you could always shape the top of the ridge. That wouldn't be too difficult to do with a 45-degree angle. And of course, how the rafters will blend in, create a flat surface through the fill area. And our blocks, we're going to shape the top of the blocks. Again, not difficult to do with a 45-degree angle. However, it would be difficult to do for steeper roof pitches than a 12 and 12. And of course, our wall here, this will be our firewall. We're going to need to have a firewall to separate the garage from the living area. And if you're going to put a door from the garage into the living area, you're going to need a fire-rated door also. And of course, a better view of how we're going to use these boards here to connect to the 2x4 wall framing studs to provide us with some more strength to prevent the wall from moving in and out. And you could always space these braces closer together. I have them at 4 foot on center. You could use 32 inches on center to make it a little stronger. Next up, let's go ahead and add our fascia board and take a look at the bottom here. And I want to kind of give you an idea if you're going to install a soffit at the bottom and the soffit's going to come all the way across here, you're going to end up with kind of a different section here. And there are a variety of different ways to finish that. I can go ahead and provide you with some of them. Just let me know if you need more information on that in the comment area. And of course, our lookouts are going to be spaced 32 inches on center, and our collar ties are going to be spaced 48 inches on center. And try to line the collar ties up if you can with the rafter ties. And we're going to move the collar tie to the other side so that we can build our wall here. So instead of having it on the right side, we're going to put it on the left side so that it doesn't interfere with our drywall. Otherwise, we would have to drywall around it. And I don't even know if you'd really need a collar tie on this one because we do have the wall. A back view of this area here. And let's go ahead and take a look at the gap between the bottom of the fascia board and the sheathing. This will allow us to install roofing materials underneath this section of the roof. And this might require you to leave some of the sheathing off so that the roofer can install the roofing materials underneath this area here. It's going to be a little more difficult to do if you have the sheathing attached. A lot of times we'll just leave a board. We'll have a piece of the sheathing that might be this big here, cut separately so that the roofer can remove this section, install their roofing, and then reattach the sheathing, nail it off, and then install their new roofing materials over this section. And I don't know if I have a video on that. Go ahead and take a look at the other fascia board corner. The blocks and how they're going to attach to the rafter tie. You could always run the block past and have the rafter tie sit behind the block if you're looking for a different type of assembly method. And of course, our shaped fascia board. And we're going to have to do some notching here to make this side here blend in with this side here. Going to have to look something like this. Next up, let's add the roof sheathing and start wrapping the video up here. Roof sheathing, not too exciting. We've seen it before. And for those of you wondering why I didn't have a full sheet here, I was about 3 or 4 inches short at the top. Or in other words, if I used a 4 foot wide piece of plywood or OSB here, I would have needed to attach a 3-inch piece to the top of that. So for example, instead of having 48 inches here, I had about 52 inches. And if your engineer does not allow for something like that, for example, if they have a 2 foot minimum, width, then you're going to need to do something like this here and waste a little bit of roof sheathing. And as always, if you enjoyed the video, let us know by hitting the thumbs up button. And if you have any questions or are interested in different types of designs for this type of construction, feel free to leave those in the comment area also.